What's up, y'all? It's Monday. Never back down. Never what? Never give up. And always write your agenda. Make sure you got your agenda written in. Yes, agenda. We are having a journal check on Monday. So pause the screen. Get your agenda written in. Not journal check on Monday. Journal check on Friday. Yeah, look at it. Journal check on Friday. So again, get that taken, and then we're going to keep it moving. If you want your scientist, please take it. If you don't, I'm going to take it. So I'm going to keep it moving. Obviously, I will have them for a few days this week. So if you're at home, you're like, I really want mine, then make sure you get it this week. If not, Mr. Farr is getting, I'm taking them all down. I'm going to keep some of them. I can't keep them all. All right, let's keep it moving. Go ahead and pause the screen. Again, pause the screen. Get these things written down. Again, pause the screen. Get these things written down. And then let's go. Did you write down your goals? Did you write down the goals? Okay, cool. So here we are. List 5 things you are thankful for. Right off the top, one of the things I'm thankful for is batteries. That's a one on my list. I love batteries. I can have things like my phone. I can have things like a remote. I'm happy with batteries. I'm also thankful for the internet. Yes, I'm thankful for that. I'm also thankful to be a teacher. Let's go. I'm thankful for my family. And the last thing that I'm going to say I'm thankful for is this chocolate that I just ate. Yeah, that's right. The chocolate I just ate. I'm thankful for food. Let's go. All right. So list 3 goals. One thing is I want to read 2.5 or 2 books. Actually, I want to read, let me think. September, October, and I'm going to try and read 1 book per month. So September and October, I want to read 2 books. That's like one of my goals. Also, the other part of my goal is to just stay on top of the agendas each week, because I haven't been getting on top of that. And then the last thing is being consistent in contacting parents. So that is the last thing that I really want to do. So those are the things I'm like working on. Okay, cool. Let's keep it pushing. I am passing out progress reports today. So again, progress reports are out today. Bring them back signed, and then you will get extra credit on Wednesday. All right, y'all. Let's just keep pushing. We did this the other day. So what is a system? Hopefully you can answer this. Hopefully you answered. A group of related parts that make a whole. A whole system can do things that the individual parts in the system cannot do. Okay, so that is review. Now guess what time it is? That's right. It's note-taking time. So let's go. All right, so what is motion? Does anyone have an answer? A lot of people keep saying movement. They said making a lot of money, right? They said that's motion. I'm like, okay, what is motion, right? When an object is moving, movement. So I'm like, we gotta get out of this habit of defining words with the same word or a similar word. So we gotta actually come to a definition. So go ahead and write this down again. Pause the screen if you need to. But go ahead and write this down. The change in an object's position with respect to time and in comparison to the position of other objects used as reference points. What do we mean by that? When an object moves from one location to another location, we would call that movement. How long, so how much time did it take? How much time did it take for this object to move from here to there, right? Like how long did that take? So again, the change in an object's position with respect to time. So how long did it take for that object to move from one location or one position to another? And these reference points we often use this in racing because we say a start and a finish line. Those would be, or like we had that ramp, right? So it's the beginning of the ramp and then the end of the ramp, right? So how long did it take the car to go down the ramp, right? So those would be reference points. And then again, with respect to time, how long did it take? All right, let's keep it pushing. Some of y'all have seen this before. This is Mr. Farr is old, so this is the first Super Mario Kart track that I played on. And again, the reference point would be here, right where the start and the finish line is at, right? You could use other things as reference points. You could say where the actual item boxes are at. Boom, that could be a reference point. Okay. Now, we usually do this in racing. So if you take a look, we have a race. You got Usain Bolt out there. So let's just take at the last time we had the men's 100-meter dash. That was in Paris. And let's just take a look at the race.
An extraordinary atmosphere for an extraordinary lineup of men. It's pretty even at the moment. Hussein trying to find a way through. Can Jamaican do it? Oh, it's so close.
9.78. That's unofficial. 9.78, 9.79, somewhere in there. Okay.
But I think the Jamaican has just done enough.
Let's see. They're not sure. They're not sure. Do y'all know who won? Do y'all remember? This was like a year ago.
Thompson just about got it, I think, from Noah Lyles.
Boom. So Noah Lyles gets it. He doesn't get the world record, but, however, like, he does win the day, which is the most important thing. So let's talk about a couple of things here, okay? Boom, bam, give me that pen, and then I want to use blue right now. Okay, so we're going to do a little bit of writing. So we're going to do this thing known as calculating speed. So that's what the S stands for. It stands for speed. Now, speed is equal to distance divided by time. So we're going to go like this and say this is time down here. Okay, cool. And this is distance up here. I always write things out this way. That way I know what each letter stands for in the formula and I'm not confused. Okay, so do you guys remember what the distance was? This was the 100 meters. So the distance that they traveled was 100 meters per second. Divided by, and if you didn't catch the time, it's okay, 9.79 seconds. Now I'm going to get my handy dandy calculator right here. Boom. But I think my calculator's on the other screen. So I'm going to go ahead and bring that calculator right on over. And then I'm just going to do the math. So 100 meters, so 100 divided by 9.79. 9.79 is equal to 10.2. So let's go ahead and, oops, I got my pen backwards. Say it's equal to, where are we at right now? Oh, there it is. Okay. Is equal to 10.2, and that is meters per second. And we'll talk a lot about that quite a bit. But this is just, so it's meters and it's over seconds, so it's meters per second. So it's 10.2 meters per second. Now, just for some reference as far as like, how fast is that? How fast are they really traveling there? Well, this might be a little, no, this is going to be, oh, no. Oh, I guess we can make it. So here's the classroom, okay? If you measure the classroom from side to side, it's about 10.1, 10.2 meters. That means they're traveling all the way across this classroom, that distance, in 1 second. 1 second. So that is how fast they are traveling. They're able to travel across Mr. Farr's whole classroom in 1 second. So that is very fast, right? Because I measured it out in class, right? I measured it out using a meter stick. Oh, here goes the meter stick right here. Oh. So I measured it out with meter stick, and I was like, yeah, 10.2 meters per second, okay? So I just wanted to get that out there so you can kind of get an idea of how fast these people are actually traveling. Now, remember, that is the average speed, which means they are actually going faster than that at some point and slower than that at another point. Usually, the beginning of the race is the slowest, because at the beginning of the race, they're going 0 meters per second, and they have to speed up. So at some point, they're probably they got to be traveling faster than that in order to average to 10.2 meters per second. So that lets you know like how fast, when you see these people out there, that's how fast they're really running. All right, let's just take a minute to talk about the metric system, okay? The metric system is the system that is really used all over the world. We use it here in the United States. It's just that we see these other units, and a lot of times manufacturers are going to put both units on there. So 7 grams metric systems, 0.24 ounces. That is the I guess you would call it the King's Imperial system. Like that's the imperial system that the United States is kind of on, right? 800 milliliters, again, metric system, and the 1.29 US pint, right? Or the 27.0 fluid ounces, right? So it kind of gets a little bit confusing. But inside of this class, just understand we are going to use metric units. That's what we're going to use. We're going to use metric units. I will teach you how to use them, so don't trip out. Take this note down. And then we are pretty much about out of time. So again, take this note down. Mass is how much stuff something is made of, and weight is how gravity pulls down on that stuff. So mass is all the atoms and molecules that this phone is made out of. Weight is how gravity pulls down on this phone, okay? So just remember that mass is how much, again, how much something is made out of, so all the stuff it's made out of, and then weight is how gravity pulls down on that. So let's just take this hypothetical situation. We usually measure in pounds, which is cool, but in the metric system, we use what is called newtons, okay? So everyone say newtons, yeah, newtons. So let's just say the mass of this phone was 45.4 kilograms. Let's just say it was. And so its weight would be different because the gravity on each place is different. Its mass remains the same. So whether I take it from Earth to the moon, to Mars, to Jupiter, the stuff that this phone is made out of, the mass will remain the same. But because the gravity is changing, then its weight, what is being pushed or pulled down on, is what's changing, okay? So again, it's the gravity that's changing, not the mass. The mass is what this object is made out of, and the weight is everything that it's being pulled down on. Okay, I think that is it for today. All right, y'all, peace. I am smarter than I think, I am braver than I seem, and I am stronger than I feel, and I can do difficult things. All right, y'all, I'm out. Peace.